Okay, this lesson is a review on ratio, and you should know already that ratio is the comparison of two numbers using division. Okay, you want to recall that the denominator can never be 0 because then our fraction would give us something that's undefined. So let's start with our first example of 3 weeks to 9 days. That's our given. You do not have to write what's on the right-hand side. I'm just using it as an explanation. The first thing that we want to do is convert to the smaller units. So in this case, it's days. So in 1 week, there are 7 days. So 3 times 7 gave us 21. Now we can reduce. So both 21 and 9 divisible by 3, that gives us a 7:3 ratio. That can also be written with a colon or as a fraction. So this applies to geometry when we talk about the ratio of side lengths. For example, the ratio of a side length in triangle ABC to a side length in triangle DEF can be written as a 2-to-1 ratio. Okay, so triangle ABC is twice as big as triangle DEF. For every one part of DEF, there are 2 parts of ABC. All right, so ratios are usually expressed in simplest form. So 2 ratios that have the same simplified form are called equivalent ratios. So the ratios 7:14 and 1:2 are examples of equivalent ratios. Okay, because a 7:14 scales down to a 1:2. We can use ratio to help us find dimension. So for example, if we're planning to paint a mural on a rectangular wall, and we know that the perimeter of the wall is 484 feet, and the ratio of its length to width is in a 9:2 ratio, we can find the area of the wall. So because the ratio of length to width is 9:2, then they must have both been reduced by some number they have in common. So it must have been a 9x to a 2x because the numbers both reduced by x. So the next thing we want to do is now solve the equation. So make sure you know the perimeter formula. Twice the length plus twice the width is the perimeter. And then we're going to substitute in our length and our width and our perimeter. Once we have our known values, we're going to multiply and combine like terms and then divide to get 22. Okay. The last part of this would be to evaluate, which means we just have to plug in. So we're going to plug 22 in for x and get 9 times 22 is 198. And then our width would be 2 times 22, which is 44. Again, this is coming from back here on how we reduced. So we made the length and the width 22 times smaller. All right, the last way we're going to be using ratios is by using extended ratios. So the measures of the angles in triangle DEF are an extended ratio of 1 to 2 to 3, and we need to find the measures of the angles. So one option we have is to create a sketch. So if you need a sketch, you can use one. If you don't, that's okay. But because they're in the ratio of 1 to 2 to 3, they all must have been reduced by some number. Okay, and that number is unknown, so that becomes our variable x. So we know that if we add x and 2x and 3x, we get 180 degrees because we know the triangle sum theorem. We combine like terms, and then we divide. Okay. The last step would be to plug x back in. So when we plug x back in, we come up with our 3 angle measures of a 30, 60, 90. And you would be able to classify this as a right scalene triangle. Okay, hopefully you were pausing the video as you go along. Now that you're done with ratios, you need to go ahead and watch the proportions video.